Imagine that for decades, small groups of people have been making things up, guided by rules and charts and lists. And those rules change every few years, and some people use different rules. And some of the best rules even say when you can ignore the rules, and random outcomes are expected. Of course, I'm describing role-playing games like Dungeons & Dragons. AppSec is completely different, I'm sure. Which means this week we talk with Anita D'Amico and Patrick Carey from Synopsys about creating better AppSec workflows with an eye towards efficiency and scalability. In the news segment, Exchange credentials make a stealth check. A vuln in IoT doesn't add up. Chrome attacks the darkness of memory safety. OWASP hits level 20, and more. Roll for initiative and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Is your mobile app really secure? New vulnerabilities pop up every day, and malicious actors look for easy targets on app marketplaces to exploit. Securing your app's valuable IP and data is critical. GuardSquare's security solutions are built for developers and protect your app at every stage in the development lifecycle. Multiple layers of protection prevent reverse engineering and automatically detect tampering, making your app a difficult target for attackers. Learn more at securityweekly.com/GuardSquare. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shiftleft. Software supply chain attacks are continuing to expose vulnerabilities in organizations around the world. The time has come to focus your efforts on security for your software packages. Cloudsmith is the only cloud-native software package management solution for your enterprise. With Cloudsmith Continuous Packaging, you can securely deliver software across the globe and mitigate potential threats from entering your supply chain. With over 23+ formats supported, Cloudsmith is the solution that engineers choose to safely deliver all of their assets. Reduce unneeded downtime and deliver with confidence. Start securing your software supply chain today by visiting securityweekly.com/cloudsmith.
This is episode 167, recorded September 27th, 2021. I'm your host, Mike Shima. John Kinsella is off this week, so I'm here with Tyler Robinson. Hello, Tyler.
Thanks, Mike. It's good to be here. I don't often get to hop on the AppSec one, so this is fun.
Yeah, we're happy to have you here. So everybody in Discord, go over, tell John you miss him, and tell Tyler hello. Also, while you're in our Discord, you can also hop over to our website to check out InfoSec World 2021 is proud to announce its keynote lineup for this year's in-person event. Hear from Robert Herjavec, plus heads of security at the NFL, TikTok, U.S. Department of Homeland Security, Stanford University, and more. Plus, Security Weekly listeners save 20% on World Pass and main conference registration. Visit securityweekly.com/ISW 2021 to register now. Security Weekly Unlocked will also be held in person this December 5th through 7th at the Hilton Lake Buena Vista. We'll have keynotes from Alyssa Miller, John Strand, Leslie Carhart, and Dave Kennedy. Visit securityweekly.com/unlocked to register and check out our exciting lineup. We've got two guests this week. Anita D'Amico, PhD, is the former CEO of CodeDX, an application security orchestration and correlation company recently acquired by Synopsys. She currently serves as the VP of Market Development in the Software Integrity Group. Her roots are in experimental psychology and human factors, and she has built a career of leading technology development to enhance human performance. More recently, she has focused her attention on enhancing the decisions and work processes of software developers and AppSec analysts to make code more secure. Anita was named one of 100 fascinating females fighting cybercrime in the 2019 book, Women Know Cyber. And we also have Patrick Carey, who's the Senior Director of Product Marketing for Synopsys Software Integrity Group, where he manages go-to-market analysis and strategy for Synopsys's portfolio of application security solutions. Patrick's 30-year career includes leadership roles in software development, product management, consulting, and marketing in a wide range of companies, from early-stage startups to large companies, including Citrix and Accenture. And with that, hello, Anita and Patrick. Thank you so much for joining us.
Hi, nice to be here today. Looking forward to it.
Great to be here, Mike.
Well, with both of you, we're looking forward to a great conversation about, as I mentioned in the intro, making AppSec better, which is one of those things that's easier to say, but perhaps harder to do, especially when we have to figure out where do we start. And Patrick, one of the things maybe maybe you can help us kick things off is that let's talk about what makes AppSec so painful. And I don't think it's the fact that there's necessarily just lots of vulns out there or lots of insecure code. I think we know there's insecure code, but the challenge perhaps is how do we go and start to understand that or start to fix it? So lay the ground for us maybe a little bit about what the pain points that the dev side of teams are running into.
Sure, and I think everybody who's listening or watching this program is aware of and probably experiencing firsthand is we continue to be in this transitional period where application security is becoming less of this downstream activity run by a dedicated team and more part of common development infrastructure and workflows. And that's a good thing, and that's required in order to enable teams to build secure software at the pace that the business demands today. But with that has surfaced a couple of types of problems that teams face as they try and plumb in these application security tools and processes into their development infrastructure. So the first of these is what I would call pipeline congestion. So this has to do with the actual technical nature of the way application security programs that have been built primarily for a model where a security analyst is running the tool, performing a scan, triaging the results, and then surfacing those back to the development teams. But when you go to try and integrate these tools through APIs, which most tools now have good API sets. When you try and build those into your automated pipelines, a couple of things happens. First off, the sheer number of tools that most teams operate and the number of pipelines that they have, particularly large organizations like large financial services companies, will have hundreds of different CI pipelines running. So that creates a lot of pressure on the DevOps teams, the teams managing that infrastructure, just to try and effectively add all those tools into their pipelines without breaking them or causing them to not perform as they were originally intended. But secondly, those tools, the AppSec tools that were meant for analysts to run directly, generally don't have response times built into them in line with the way modern development pipelines operate. So a typical build pipeline may be targeted at completing in a few minutes or even just a couple of minutes, but an AST scan may take 10, 15, 20 minutes or more. And those two speeds are at odds. The other thing that happens when you automate these tools, particularly when you have a lot of tools, and we've done research where the average team we see has a dozen or more different AppSec tools in place, is all those tools are generating findings. And so by automating, you sort of increase the rate at which you're doing this analysis, and you're compounding the problem of the number of findings that you have to triage and work through. So that can actually overwhelm the team with just that triage activity to try and sort out the signal from the noise and figure out which of those findings are true positives, weeding out things like duplicates, or even just trying to understand the different findings from different tools who may use different metrics for reporting the severity or priority of those. So the combination of those is often a big hurdle or a complete wall that the development teams face when they try and build security into those development workflows.
Yeah, I think to me, a key point what you're describing there is that, sure, we can throw more tools into the problem, but that's not necessarily making things better, especially if these tools were designed, kind of as you were pointing out, for the AppSec role to deal with. Why then would you take these tools that were designed and geared towards an AppSec needs, put the responsibility onto the DevOps side, but not adjust the tools to follow along? So I'm kind of curious then, maybe Anita, if you know, now that we understand some of the challenges here and the idea that we're not necessarily going to successfully scale just by throwing more tools and generating a lot more vulnerabilities, as Patrick was saying, there obviously, ASOC is coming in here to do something better, but, give us a little bit of insight into how that can be better for teams.
Sure, Mike. As Patrick said, the developers are faced with many different tools and lots of different issues that are found by them, and they're on a time crunch. They need to be able to analyze the most important ones first. And this is where ASOC systems play. ASOC solutions, that stands for Application Security, Orchestration, and Correlation. And what it does is it automates some of the most labor-intensive parts of analyzing the issues and figuring out what to fix first. So let's take this apart. The first part of application security, orchestration, and correlation is orchestration. And what these types of solutions do is they orchestrate the many different tools that have to be run. That means that they automatically configure and run them. And it's not just the same tool all the time. Depending on where you are in the software development lifecycle, it will pick the right tool at the right time. So that's orchestration. The second thing that an ASOC system will do is it will correlate the many diverse results that you get from all these tools. You might run 2 static analyzers and a DAS tool and a software composition analysis tool. And what an ASOC system will do is it normalizes all those results to a common nomenclature and correlates the findings. Now, what happens when you correlate the findings is you find duplicates. And so it gets rid of the duplicates, it deduplicates. And developers love this because once they see an issue, if they resolve it, they don't see it again. So that's the second thing that an ASOC does, is orchestration, correlation. The third thing, and the thing that's probably of greatest importance to the developer, is prioritization. We know you're going to find thousands of issues. Which ones do you fix first? And which ones do you not even address? An ASOC system will prioritize these issues for you. It'll typically do it with some kind of rule set that you set up, but it can also learn from a developer using machine learning what that developer considers important and what is not important. And then it'll recommend which issues to escalate and which ones to leave on the cutting room floor. So that's the prioritization part. So we've had orchestration, correlation, and prioritization. The fourth thing that an ASOC system does is track remediation. Now, as a developer, you don't want to leave your environment. You want to stay in your environment. And a good ASOC system will take the high prioritized results and automatically hook in to your issue tracker, like Jira. It'll push the issue to you as the developer, along with remediation guidance. Sometimes it'll even offer training. And then when you resolve the issue, it can close the ticket automatically. So those 4 things are done automatically for you. And then the fifth thing that an ASOC system does is it puts all of that information in a centralized platform where you can get at it immediately. You could figure out what tests were run, what was found, and whether it was fixed, and all from a centralized risk management platform. So that's kind of what it does in a nutshell.
No, I love that the areas that it addresses, and I do want to dive in on some of that prioritization bit, because that's where a lot of where I see some of the, we'll call it friction, some of the challenges, to use the kinder words, the DevOps teams run into, because they suddenly have lots of tools. They may be deduped, but even those deduped, list of vulnerabilities may be a really, really long list. And so, there's some naive ways we could say, here's how you prioritize based based on a CVSS score or something like that, or here's the OWASP top 10 category it belongs to. But I imagine, or at least I hope, there's got to be some richer conversations to have around that, about how you approach the prioritization. So I'm kind of curious how you've seen, organizations either adopt that, add some of that business context, if you will, or just figure out how much of that prioritization can be automated or does still require those conversations between your AppSec and your product teams.
Well, every enterprise is different. And what one enterprise thinks is important to be escalated, another enterprise may consider to be unimportant. So it is important when you field or deploy an application security orchestration and correlation system that you sit down and figure out what is important to escalate and what's important to just disregard at different points in the SDLC. And then using that information, there are a couple of things that you can do. One is setting up customizable rules. And those rules can be specific to where you are in the SDLC. So what goes into those customizable rules are things like industry standards. So there are like the OWASP top 10, SANS 25, but there's also regulatory standards like PCI, or in automotive industry, MISRA, or HIPAA, or DISA-STIG. So you take those into consideration. You also look at the business impact. And this is something that is really important in terms of prioritizing risk. So you may look at the specific types of vulnerabilities and say, these are, or weaknesses, these are the kinds of things that are most important to our enterprise. And so what you do is you put that all into a recipe for what to prioritize high and what to prioritize low. So that's the first thing that you do in terms of the prioritization. You meet, you talk, you say, what do we want to escalate at which point in time? Then, if you have a machine learning system built into your ASOC system, it will then learn over time what the developer or the analyst thinks is important to escalate and what they think is unimportant. And that can be specific to a software project. So it's not a one-size-fits-all. For this particular software project, these things are important.
No, that's pretty compelling, and it starts to, this idea of metrics. I think that ties into that fifth point you were making too, that centralized platform, that capability for governance, and especially as you're talking about MISRA, HIPAA, PCI, DISA-STIGs, et cetera. So I'm curious, and maybe you or Patrick want to dive in on this one about what are some of those metrics that are actually helpful that you've seen successfully used within DevOps team, AppSec teams, using these types of tools. And I'm going to guess off the bat that just saying, here is the total number of vulns that we found and fixed probably isn't really reflective of risk, or just, a vuln count isn't just what we want to go after. There's got to be some, what's the more meaningful things that you've seen useful?
I can take that. So in our experience, there are two types of metrics that people are interested in. One is, what is the status of the software security? And the second is process improvement. So let's start with the status of software security. A lot of these ASOC systems will give you a risk score, and it'll be a separate risk score for the custom code versus the third-party components, and they can even give you a risk score for the risk to the software system from the network on which it resides. And so the first thing is to say, numerically or alphabetically, what is the risk score for each of those three components. The second thing is, how is that changing over time? So are we getting better or worse? Are we introducing more issues faster than we're resolving them? And that sort of is on, that's both a software security metric as well as a process improvement metric. We can also look at time to remediation. So if it's a high critical vulnerability, how quickly is that remediated, and how does that compare to our policy? So again, we can look at areas for process improvement. Another thing that people are very interested in, especially developers, is, are there certain types of weaknesses in the code that permeate the group across the software projects. So no matter what software project you're running, this particular set of weaknesses are the ones that seem to predominate. And if so, then you've identified an area for training. And management can give training, and or you can have training built in to an ASOC system and reduce those common vulnerabilities. So there's just a few of the metrics that we see widely used.
That's helpful to know, and especially to the last part. I'm always curious about the success of training, which clearly is an important just to build that awareness, appreciation of AppSec, as well as introducing frameworks, because I know that there are trade-offs there between the time investment and who's taking the time to either go through training or to be able to apply a new framework against SQL injection, cross-site scripting, CSRF, for example, whether that's on newly developed software or unfortunately legacy software where it can be a bit more difficult. So I'm curious maybe to dive into that. What are some of the other ways that you've seen organizations kind of react to some of those more pervasive issues, or how they react perhaps to some of those metrics? Is it the idea of training does become a pretty critical aspect? Do they start to make changes in designs, changes in even programming languages or practices that you've seen? And I'm getting poking a bit too here at sort of that behavioral aspect, because I know, Anita, that's some of your background too, in that we're talking about here about making things better for developers. We're not just saying purely fix these technical flaws with all these technical automated solutions, because obviously that doesn't work, in a complete vacuum.
Well, one of the things that I'd say is that there all of the things that you mentioned have a role to play. There's no silver bullet for sure on this, and what teams are seeing is that the developers that are on staff definitely are not coming into the organization often with much in terms of application security skills or training. So certainly trying to provide a continuous training and education as a component of application development, and trying to do that as the developers are writing code and continually reinforcing that is a part of the equation. And because of the organizations often have a deficit in terms of security professionals on their team, a lot of teams are also extending that with things like security champions programs. So establishing beachheads in each of the security teams with a developer or a handful of developers who will get additional training and become sort of the representatives of the AppSec team within the development group. That's certainly a portion of it as kind of continuing education above and beyond just even kind of what the AppSec team is doing based on the metrics coming out of these types of tools.
No, that's interesting. I think, too, so one of the things that you said wasn't so much that security champions are just the ones running the tools, because that doesn't seem like a very compelling or necessarily the smart approach here. It's the security champions are interpreting those results in the language of the DevOps team to understand, here are the engineering trade-offs we need to make. Here are the decisions we need to make to keep up with the normal features and product development that we have to do on top of addressing these security vulnerabilities. I'm curious then if, are there ways that you've seen the security champions be a bit more, be more successful, or ways of growing that? Because it can be one of those things that's tough to curate over time. And I've seen mixed success, unfortunately, and would love to see more success within orgs trying to adopt that model.
So I think it is, certainly an ongoing challenge, and it's really has to be done in concert with, as you pointed out, the security champions, not as the representatives on the team who are doing the security testing, but who are advocating and helping facilitate education of the rest of the development team on secure design, secure coding practices, remediation practices, and understanding of what some of these risks are, in concert with things like on-demand security training, e-learning programs and the like, because really you need the developers to take on that role as sort of the front line of defense on security issues, and to try and build those habits. And there too, I'm not sure that there's a silver bullet. And as Anita aptly pointed out, every organization is a little bit different in terms of the aptitude, their capacity, and the prioritization they place on secure development as a practice.
Yeah, I'd like to comment a little bit on the human behavior. As you know, my background is as an experimental psychologist, so I'm very interested in the psychology and the human behavior that goes around secure code development. And one of the things about people learning about security in their software is that there's really two types of learning. One is the kind of learning that you get when you have just-in-time learning. So you're doing remediation and you need to learn about this particular vulnerability, and so you call up a learning module. And you can do that with e-learning, you can do that inside an ASOC system. And that's a certain kind of learning that reinforces very strongly the fact that you need to learn this because you're faced with a problem. But the other kind of learning is more collegial, and this is where the security champion really plays. And as Patrick said, the security champion is not there as an analyst to vet everybody else's code, but to have a collaboration. And that term is very important, that developers collaborate, that they learn from each other what is important in terms of the security of the code. And by the way, that collaboration works really well when you have a small group of developers working on the same files. But studies show that when you start expanding the size of the team, let's say more than 6 or 7 people working on the same area, that the collaboration starts breaking down because there's just too many people. So I think the important part of the security champion is that he or she work collaboratively and in a lot of regular communication with all of the team members.
That's cool, because it also sounds like some of the just-in-time aspect can also, unfortunately, maybe have a little bit of a punishment aspect to it. I think, I know that's not what you were describing there, but I'm thinking more of like phishing training, that someone that I think poorly designed phishing tests will say, oh, someone clicked on a link, therefore you are now punished with having to learn about how to interpret a navigation bar in a browser. Probably not the best approach. It does sound better to have contextual information to say, oh, this tool identifies here was a cross-site scripting. Here's something that is some very brief training just in time about the cross-site scripting countermeasures for the specific language you're working in. But even better, that collaborative aspect of that small group with that security champion talking with them. And I guess one of the questions I want to ask too, then, what are some of the good behaviors, or I'm reusing the term behaviors, just practices, attributes, what makes a security champion successful? Because I suspect it's actually more than just really understanding the code base that everyone's working on too.
Patrick, did you want to take that, or do you want me to take that?
Why don't you, if you can, go ahead and take a crack
Sure.
on it, and I may add to that.
Okay, so the security champion really has to be a good communicator. And people will learn better when things are put in a positive light and where there are examples given. So I think that's one of the important characteristics of a security champion. The other thing about the team in general is that they learn more effectively and produce more secure code when the team and the individual developers on the team are working on just 1 or 2 things at a time. So focus is very important. The security champion will be able to do a better job with the developers, and the developers will write more secure code when they're just focusing their attention on 1 or 2 files. There's a lot of research that shows in the open source community that when developers start distributing their time across a lot of different files, they introduce more vulnerabilities in the code. So attention is really important.
From my time, my career, I started out as a software developer, and I think one of the shifts that we're seeing with this is it's an ongoing challenge that our teams face in working with AppSec teams, and as they try and do this shift left, is to move the perception on the development team of application security being this tax or this penalty that's imposed downstream that causes them to have to go back and open up code that they thought they were done with and rework things. Right? As a developer, that's sort of the worst thing you can imagine. But developers have a lot of pride in their work product, right? They want to build high quality code, and so the mind shift here is to bake that idea of security as being part of building a high quality product, and to move that early enough where I can finish my project and feel confident that what I produced is both secure and high quality, and I'm not going to have to go back and do rework downstream. And that's part of the role of both of these, both the champions and early stage training and e-learning, is to try and make that part of the craft of software development and not a tax at the end.
Yeah, I think, and it sounds like that ASOC, to tie it back to that too, also helps us out here, especially on that aspect of focus. If we can get we can filter down all of this slew of vulnerabilities down into a prioritized list that actually enables developers to focus, as well as being able to have these tools be able to run wherever appropriate within that CI/CD pipeline, so that they can avoid fixing yet again the same flaw that keeps getting found, and have a better understanding about getting down to that root cause or that underlying framework issue, some other way of refactoring the code just to make their lives better. So all in all, that sounds like a pretty compelling story for having security just being part of software quality.
Sure. And when you think about an ASOC system, remember that the first is orchestration. So when you get all the way through the process and the developer has remediated the code and has submitted it back into the issue tracker, what an ASOC solution can do is then go back and rerun the tests, only like just the tests that need to be done, reorchestrate. And that way the developer gets almost immediate feedback that the fix that he or she did has been effective, because you can just reorchestrate that particular test.
I have a question around like bug bounties and like 0 days, things that come out of the woodworks out of nowhere. Does that kind of throw a wrench into this ASOC framework and how developers are addressing priorities?
Well, a good ASOC system will take in all kinds of input. So it's not just SAST tools or DAST tools or IAST or SCA, but a good ASOC solution will bring in the results of manual code reviews, of bug bounty information, of manual pen testing, even architectural security and security requirements. And all those things can be correlated in the system and factored into a single pane of glass, basically. So yes, bug bounties can be included, and they're part of the entire risk picture that's presented in a unified system.
So I guess maybe along the lines of that, as we sort of start to wrap up here, what are some ways that then you think that what does the future hold for ASOC or this type of correlation? Meaning, should we be pulling in yet more sources of vulnerabilities, be they the threat intelligence about 0 days or bug bounty reports from external platforms to additional tools that may be pulled in? I guess maybe it's sort of a multi-part potential here in terms of, is it more tools? Do the tools just also need better APIs to interact with these, or better decoration of the types of issues they find to make it easier to prioritize? I suppose if you could pick one thing, what might that be to make this future of AppSec more easy to automate and more informative for developers?
Well, one of the things that you mentioned early on is you asked the question, like, why would you take these traditional AST tools that were engineered and are designed for the needs of application security analysts and throw them into your development pipelines that are meant to be these automated, headless, high speed workflows. And that points to where really things we see will need to change going forward. So ASOC solutions do allow teams to leverage their investments in their tooling that they have today, because no organization can just swap things out overnight. They have a lot invested in both the tools themselves, but the skills and knowledge they have around the tools. But what we see is that as application security folds more into development workflows, that those traditional silos between SAST, DAST, SCA, IAST are going to start to break down. And what teams are going to be looking for is a more services-oriented model where they can combine any number of analysis techniques in these development workflows. And ASOC solutions will be central to managing that with a combination of your legacy tools and these new services as they emerge.
Yeah, that sounds great. Especially the idea of that spirit of breaking down silos is this conversation. If we hopefully a year from now, if we have it again, we'll be talking less about AppSec team, DevOps team, and it's more of that just small group, kind of perhaps as Anita was describing, that's just focused on this particular portion of the code base or this particular product or feature, and they're the ones that are responsible for the security as well as they are for developing it, and they just have some tools helping them along the way.
Yeah,
that's right. And what you're going to see, what you're seeing now, as well as I think you're going to see more of in the future, is that people aren't going to have fewer tools. I mean, all of the data shows that people are getting more and more tools. Enterprises are running. The average enterprise is running more than 10 different application security testing tools. But you're going to see lighter weight versions of these tools, and you're already seeing it, earlier in the software development lifecycle. So you may not run the entire big SaaS solution in the beginning of the SDLC. You're going to have lightweight tools that developers can use just to get the most important stuff first, and then you'll get different levels of the tool use as you progress through the SDLC.
Well, even if we have some lightweight tools, the both of you have brought some heavyweight information for us for this particular segment. So I want to say just thank you once again, Anita and Patrick, for joining us.
Thank you very much for having us.
Yeah, thank you.
Also want to thank Tyler and everybody who's been hanging out in Discord. If you'd like to learn more about ASOC and Synopsys, visit securityweekly.com/synopsys. And with that, we're going to take a quick break.